Well, hello there, moles. Here we are now on section 3 of chapter 10, day 1. There's this be a short note today and then another one for tomorrow. Before we actually do our notes today, we are going to do a quick warm up. So let me pull up the warm up for you. This is to review section 2, where we learned how to make confidence intervals using T star because sigma, the standard deviation of the population, is not known. So I want you to work on this problem. And it is 21. Notice it's random sample, 21 young college students. They were asked how many units they were taking. So please create from this data set here a 99% CI for the true mean number of units taken by young college students. So state, plan, do, conclude, sketch is always a part of all of our work that we do with confidence intervals. So state the problem, and the parameter must be in that. Plan out your 3 conditions of SRS, normality, and independence. Then do the work and write a conclusion and sketch your drawing. At this point, I'm going to pause and to let you do that work and put some answers into Edpuzzle. Okay, hopefully you got that done. And the next thing that I want you to answer is this. So we learned that we need to figure out how to find N. What sample size should I use, Mrs. Straub, if I want to keep a margin of error here at most to be 1? Okay, so using the same problem, go to your margin of error formula, but notice I put in the notes what we learned in section 1 was we used Z star times the thing. Well, now we've been in T star. However, I can't use a T star if I don't know N, because do you remember T star is dependent on N. Since I'm trying to decide N, I'm going to use the most conservative number, which would be the Z star all the way to infinity. So we're going to use Z star for 99% CIs, which you can find on your table as I've shown you, your table B at the bottom. So set up a margin of error formula just like we did with the Z star formula in section 1 and tell me what would be the at least how many would you need to sample? Okay, then we'll come back and check answers. Okay, I'm gonna go to the answer key here and let's see how we did with both of these now. Notice in your state that you should have had that we are constructing a 99% CI for the true mean number of units taken by young college students. So notice my state has what it is we're constructing along with my true parameter and context. I wrote down all the things I got from the problem. If N is 21, then DF is 20. The confidence level is 99. I put all this data into my calculator and ran one var stats to get X bar S. And then I looked up the T star for 20 and a 99 CI and got this number. Okay, so that's just data that I collected before I got going. My plan then, SRS was given. Okay, normal, yeah, we don't have 30, but that's no problem because I go to the probability plot and I see that it is fairly linear. So if you remember from section 2, that if we get a fairly linear probability plot, then we don't need to say proceed with caution. We could say we are going to assume because the probability plot was fairly linear. And then on your test quizzes, you must draw a sketch of what you got in your calculator when you ran the probability plot on these numbers here that were put in. Okay. Independence, we're going to be assuming that there are more than 210 young college students, and there are. Okay. The do, I just rewrote the formula here and then plugged in all of my data elements from one var stats and finding my T star. And then got this confidence interval. My conclusion is we are 99% confident that the true mean number of units taken by young college students is, notice my parameter, my context, between, and then put the two contextual pieces there. Okay, so hopefully they're ready for that, because Wednesday's quiz is going to ask you to do exactly what we just did. Now, what about finding the sketch down here? Remember that you put your 99% in the center. My mean from the sample was 17.19, I believe, yes. And then my 2 endpoints from my interval and shade in between. So this is quite an easy sketch to do. Just remember to do it and write that you've got 99% shaded there. Okay. Moving on to question number 2, what's the least number of people needed to be sampled? So here is our Z star for 99%. And then here is the S divided by square root of N. I'm divided 1 by 2.576. Let's see, what did we do here? Oh no, I cross multiplied, sorry. Times 2.576 times 262, that's that number right there. And then the square root of n times 1 is the square root of n. Since this is coming over to this side multiplying, that's where the greater than square root of n is greater than. And then square both sides. So you need to sample at least 46 students. Okay, so now you've done one of these when you know sigma from section 1, and now you've done one of these when you don't know sigma from section 2. Okay, all right, so let's get to the notes. Back to the notes. Okay. We're going to move on today to what do you do when it's parameters. And these are short because basically it's exactly the same thing except for the couple of changes we have to make for parameters. Okay. Before I jump into that, there is one big question that will be on your test, okay, and quiz that you need to remember. And that's things like, what is the difference between Z star and T star? So I tried to put a couple sentences here. First off, here's the difference of when you use them. We use Z star for our normal distribution of means when sigma is known. And we're going to use it for proportions, as I'm going to show you today. So Z star is always for means if you know sigma, and always used for proportions. Whereas T star is used for means only when you don't know sigma and you have to estimate with the standard deviation of the sample. Okay. What about the curves? How are the curves different? So a T curve, remember I talked about this in section 2. It's not a normal curve until basically n is super big. So the T curve is typically shorter or flatter, if you will, in the middle, and it has more area in the tails than the normal curve of the Z does. Okay, the Z is symmetrical and you've got it very symmetrical. I kind of use it as an example of like someone's pushing down on the top of the normal curve, so it makes it flatter here, but when you do that, squishes more into the tails. So you have this fatter tails, flatter center, and more in the tails, whereas a normal curve would have a higher mound and then less as in the tails. Okay, so keep those in mind because those will be great true false multiple choice questions on the test. Okay, so as we jump into proportions, we need to go back to chapter 9 and recall when we did the sampling distribution of our p-hats being our sample proportions. Okay, we found, and I did a big proof for you back then before we had to go home, this was in the classroom still, that the mean of all of those was exactly the population parameter P. And we came up with this formula here as our standard deviation. Now, you don't have to memorize this. Remember, this is on your formula sheet. So keep your formula sheet handy this whole lesson. You will need it. And make sure you know where to find this for proportions. But that's that P times 1 minus P over N square rooted. We also found this in chapter 9, that if n is large enough so that np and n times 1 minus p are at least 10, then we can use normal approximations. This is our normal condition now. When you go to do a CI on a proportion, we cannot use CLT. Do not use CLT. It's the number one mistake students make. They go, oh, n is greater than 30, so it's normal. That does not work for proportions. That's only for means. This is the condition you must satisfy. So you're still going to do SRS and you're still going to do the 10N, but your normal condition is no longer CLT and probability plots. It is this NP, and N times 1 minus P must be greater than 10. Okay? All right, or at least 10. So let's see what we're going to do. Just like with means, realistically, we don't know the population parameter. So we take large samples, and that P hat's going to be really close to P. And I gave you, when we were in class, we did a little applet and we saw how it just really did. The more we took it and the larger N got, the more and more we were getting P all the time. Okay, we averaged all of our samples out and we got P, the parameter. So we're going to replace P with our P hat, since it's going to be getting it's a good estimator. It's a non-biased estimator. So remember that P hat is your proportion of successes out of your sample size. So 10 out of 20, whatever it was you got. If I'm looking for how many heads will I get, and it's a non-weighted coin, 10 out of 20. Okay. And then this is our standard error. It's the exact same formula we just looked, but remember we are replacing P with P hat. So note the P hats here. P hat times 1 minus P hat over N. Okay. So now our confidence interval is the same as it's been. Same thing we did with means. That estimate, but now our estimate is not X bar because we're not doing means. Our estimate is P hat. So it's going to be P hat plus or minus, and then this is our margin of error out here. We're back to using Z star, as I just explained in the first slide. That proportions use that Z star number. So you do the same thing. Go get that Z star for the percent confidence level that you have. And then you're going to multiply that by now our standard error of the P's, which is this new formula here using P hat as our estimate. Okay, so let's do one. Oh, wait, forget. Sorry about that. I need to go through the conditions again. So remember your same conditions: SRS, normality, and independence. However, you like my colors, by the way? Yeah, trying to make it a little bit more pleasing to the eye. But recall that we're not using CLT. I just went over that. Okay? And so then this is your confidence interval that you will create. And your conclusion is the exact same thing, except for now we're not saying true mean. We're saying true proportion. Our parameter is just changing from means to proportions. We are 95% confident that hasn't changed. The true proportion of, and then put your context in, is between, and now we're doing percents. This percent and that percent. With means, it was quantitative data. Proportions goes back to categorical, so we're getting a percent of that categorical data. Okay? And you write it just the same way. Put your two endpoints in parentheses. Okay, now let's see what one looks like in practice. Move my head out of the way. Okay, so now we have a random sample, SRS given, right? 16 out of 24 stat students ate dinner after 7 p.m. So create a 95% confidence interval for the true proportion of stat students eating this late. Okay. Put it back in here, sorry. First off, I'm going to calculate my P hat. P hat is this 16 out of 24. You're not always going to be given the percent. You need to read the problem carefully, and it's given as a fraction or a ratio here. Take the ratio and create it as a percent. 16 out of 24 is 0.67. So that's my P hat, my sample proportion. Okay, I didn't do the state here, but you would state we are creating a 95% confidence interval for the true. Basically, it's this last line right here should be your state for the true proportion of stat students eating after 7 p.m. That would be your state. Okay, conditions, state, plan, conditions. SRS was given. We run our normal condition N P hat because we don't know P, so N times P hat is 16. That one's good. But n times 1 minus p hat is only going to give me 8. I think I have a little, yeah, that's not greater than 10. So we need to proceed with caution. We don't have everything satisfied here. N was not quite large enough. Okay, 24 is not. Independence, 10N. There, we're going to have to assume there's more than 240 stat students in the district, or I know it's not that at MVHS, so we'll have to say we're assuming it from our district. All right, go ahead and creating the confidence interval. Now's the do part. Notice the formula there. I filled in the pieces, getting my Z star for 95%. CI, confidence level, and then here's p hat, 1 minus p hat all over n, square rooted, and I end up getting this at point estimate. Remember, this is called our point estimate, 0.67 plus or minus the margin of error, 0.188, and I get a confidence interval of this. That's pretty wide confidence interval because my n is so small, huh? And then your conclusion will be, we are 95% confident that the true proportion of stat students eating late, or you could say even after 7 p.m., is between, and now here's where you change those numbers back to percents, 48.2 and 85.8%. Wide range, okay? But we can say that we're pretty sure it's in there somewhere. So if you see, nothing has changed. It's the exact same process. State plan, do, conclude. State plan, do, concludes are all the same. The only thing that has changed is now it's proportion. So we use a different normal condition and we use a different standard error formula, and make sure we go back to the Z star to get it when we make our margin of error. Okay. So just a reminder that here's your 4 steps to follow. State is stating your parameter, whether it's a mean or a proportion, and the context it's within. Okay, no matter what your CIs are, whether they're means or proportions, these are the same 4 steps. State what you are finding. Okay, your conditions, check for SRS, normality, independence. This is your plan. Your do is then do the appropriate formula. So you have to know whether it is X bar plus or minus Z star times sigma over square root of n, or X bar plus or minus T star times S over the square root of n if you don't know sigma, or if it's proportions, the one we just did, P hat plus or minus Z star times, and then the SE formula, that P hat times 1 minus P hat over n square rooted. Okay. Then finally, a conclusion where you interpret your results, making sure that you are saying we are C% confidence. And I should have noted here, remember context in your conclusion. All right, that's it for section 3 notes. Work on the homework, and I'll give you some more on section 3 tomorrow, and there will be a quiz on section 2 tomorrow. So then get out of this and close out.